Okay, stats. This is the second half of section 4.3. This is Tuesday. We're starting with part 3, which is Bayes' theorem. And they're going to give us a little bit of a scenario here for example 4. And then I kind of like to organize our thoughts into something that looks like this. So it's that two-way contingency table, except we're talking about positive results, we're talking about negative results, and here we're talking about cancer, no cancer. So like somebody has cancer, testing positive for cancer, somebody has cancer, testing negative for cancer, that type of thing, okay? So the little scenario that they have going on here, it says assume that a 1% prevalence rate, meaning that 1% of the population has cancer, okay? And they denote that as P of C equals 0.01. So P of C, I'm gonna write that down here, equals 0.01. And 1% has cancer, okay? For a subject randomly selected from the population, this result is included with the following performance characteristics for the test of cancer, blah, blah, blah. Okay, they want us to calculate this, all right? Find P of cancer given a positive test result. Okay, they want me to find that. And we did that up here. We talked about in example 2 how to find that conditional probability when you have the given stuff, but that's if you have the numbers already. So what we're going to do is we're just going to use these percentages that they give us to identify what these numbers are, and then it'll be really easy to solve for, okay? So one other thing is that right here they have like another little piece of information that says the false positive rate is 10%. So I'm going to say false positive equals 10%, and a true positive is 80%. So true positive equals 80%. Okay, so we're going to look at those two things happening, and we're going to fill in some numbers. Okay, so when I have this table here, it doesn't matter what number I put in for the total, and you know, do the calculations based upon that number, because we end up reducing that. So I just start with a really big number as a total, like 100,000. And by starting with 100,000, when I do all these calculations to it, it's very unlikely that I'm going to get a decimal, right? If I take 1% of 100,000, it's not going to be a decimal. It's going to be a whole number, okay? So I start with a really big number because it doesn't really matter what our total number is to start with. Oh, wait a second. I shouldn't do that. I want this number to be, don't kill me. Don't kill me. Sorry, I'm erasing. So 100,000, I want to be this total down here. There we go. That's what I want, okay? So, all right, the probability that somebody has cancer is 0.01 or 1%, okay? So if I do 1% of 100,000, that's just going to be 1,000, okay? So that's total people across the board that have cancer, all right? That means that I have 99,000 that don't have cancer. Okay, now of these 1,000 that do have cancer, I have false positives. That is, let's see, I have a false positive that's 10%. Okay, let's talk about a false positive. False positive, let's see. False positive would be this guy right here. Okay, they have a positive test and they don't have cancer, so that's the false positive, and that's happening 10% of the time. Okay, a true positive is going to be this one right here, and that's happening 80% of the time. Okay, so I hope that made sense. A true positive would be testing positive if you do have cancer. False positive would be testing positive if you don't have cancer, all right? So 80% of the time, I'm going to have this thing happen, all right? And so what we do is we look at the total cancer people, and that is 100,000 or 1,000, and I take 80% of that, and 80% of that 1,000 is 800. People are testing positive, which means I have 200 people that are not testing positive, which is kind of unfortunate because those 200 people are going undiagnosed with cancer. So that's kind of a pain in the butt. And then 10% of the time, I'm getting a false positive. So 10% of these people would be like let's see, I moved the decimal, 9,900 of those people are testing positive, okay, which means I have to do some math here. If I subtract those, 99000 minus 9900 is 89,100 is going in this spot, okay? And then I can add, so 89,300 are total negatives, and total positives would be 10,700 would be my total positives, okay? So I hope that kind of made sense. You know, your false positive and false negative, false positive, true positive rate is going to tell you what percentage you take of these total numbers, okay? And then that gives us that information. All right, now I just go and answer the question. So the question is, I want to know the probability of probability of cancer given positive, okay? So we start with our given, and this number right here. We're not talking about all 100,000. We're only talking about the positive people. So the positive is that 10,700. That's going to be my total bottom number. And then of those people, how many have cancer? That's 800. And then I can just drop some zeros. So I have 8 over 107, which is about 0.075, which is about 7.5%. Okay, and that is the probability of getting somebody that has cancer given they have a positive test result. Okay, all right, that is fine. Yeah, okay, all right, so moving on, you guys have on the very, very back side, you have another sheet that isn't a part of your notes, but it's just kind of the same type of thing again. We're going to do maybe a couple more of these and then we'll stop, okay? And then you guys can just work on your homework assignments. So this one says there is a 2.5% probability that a Schnauzer breed of dog coming for a visit to a vet clinic has a certain type of skin condition. Okay, so has skin condition, no skin condition, test positive for skin condition, test negative for skin condition, okay? We have a 2.5% chance that the Schnauzer breed of dog has this skin condition, okay? I'm going to start off with 100,000 because it doesn't matter what this number is, this total number. We just want to make it big enough that we don't have decimals. So then we're going to take 2.5% of that 100,000. 3 times 0.025 as a decimal, if you want to write that down, 0.025, and that is 2,500. So 2,500 have the skin condition, okay, which means that 97.5 do not have the skin condition. Okay, so that gives me my total numbers. Then it says the vet has a test that is 94% accurate at detecting the skin condition, okay? So what that means is that 94% of the time they should test how they're supposed to, okay? So if I have the skin condition, I should test positive. This is happening. This is what's supposed to happen. If I don't have the skin condition, I should test negative. That's what's supposed to happen, okay? And that is happening 94% of the time. 94% of the time this is happening. Then 6% of the time I'm getting a false negative, and 6% of the time I'm getting a false positive, okay? So that's kind of how that works. And then what I do is I just look at these numbers, these total numbers over here, and take 94% of this guy or 6% of this guy and fill in the blanks, okay? So if I take 2,500 and I take it times 0.94, that is 2350, okay? And then you can take 6% of that number, or you could just subtract these two to figure out that blank. It doesn't matter. I'm going to just subtract, and this is 150, and then we do the same thing for the bottom number. So 97,500 times 0.94 is 91,650, and then if I subtract that, okay, it's 5850, okay, and then I can add those guys together, 2350, and I get 8,200 are the total positive people, and then total negative people would be 91,800 would be my total negatives, okay? And now we're going to answer some questions based upon this table. I've got lots of circle things going on here, so let me get rid of some loops and bubbles and everything so we don't have such a mess. Okay, blah, 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 blah. Okay, there we go. All right, so he's cleaned up a little bit. All right. Find the probability of the skin condition given that the test result is positive, okay? So I'm going to do probability of condition given positive, okay? So we start with just the positive people. That's the number below here. And just the positive people, that's a total of 8,200. And of those people, how many have the skin condition is 2350, okay? And then I guess I can delete a zero here. I'm just going to convert it to a decimal. So that is 0.29, let's say. So 29% of all of the schnauzers that that tested positive, 29% of those actually have the skin condition. Okay, so here's the deal. Of all the dogs that are testing positive, only 29% actually have the condition. So here's the deal. Do you think it's a good decision for the vet to treat every dog that tests positive? And part of this, I guess, is kind of an opinion, but part of it is like, you know, just look at the numbers. So I guess it kind of depends on, you know, like how invasive is the treatment? Is the treatment going to be like injections that they get or whatever? Or is it just like an ointment treatment? If it's an ointment that's not going to harm them, you might as well give it to them. But looking at the numbers, only 29% of the people who test positive or the dogs that test positive actually have the condition. So it's probably not, just by looking at the numbers, not even thinking about the treatment, it's probably not a good idea to treat everybody. No. I'm going to say, do you think it was a good decision for the vet to treat every positive number? No. The majority, and by majority I mean 71%, right? 71% don't actually have the condition. Okay, that's kind of what it boils down to. Okay, you might say, fine, go ahead and give them the treatment anyway, because if it's not going to harm them, you know, we might as well. But if that treatment costs a couple $1,000s, now that might change your mind, right? Let's make sure they for sure have that condition before they treat it. So how do we determine whether they have the condition or not? That kind of goes back to the repetition thing. You know, like we're going to put 2 engines on a plane just to make sure that if one fails, you know, the plane's not going to go down. Kind of along that same lines, we're going to give them the test again to see if they're testing positive again. And if they test positive twice, chances are they probably actually do have that skin condition. Okay, so that's kind of how that works. All right, let's do one more. Number 2. We have this already ready to go. They put 100,000 in here. The veterinary knows that 1% of the dogs in the country have the virus. So 1% have a virus. Okay, 1% of 100,000 is 1,000, so 1,000 has virus and 99,000 doesn't have virus, okay? All right, there is a test for the virus that is 98% accurate, which means 98% do what they're supposed to do. Okay, 98% of the time it's going to do what it's supposed to do. Like if you test positive, you're supposed to have the virus. This should happen 98% of the time. If you are testing negative, you don't have the virus. That's what should happen. You should test negative if you don't have the virus. But 2% of the time, you're getting false negatives or false positive, and that's what's happening there, okay? So starting with this 100,000, 98% of that would be 980, which means 2% is 20, okay? These numbers are kind of nice until we get to the bottom one, 99,000, and if I do times 0.98, this number is 97,020, and if I subtract that, that is 1980, okay? And then I'm going to add that to the 980 to get my totals, so 2960, and this number would be 97040, okay? So that's kind of how those numbers work out, okay? Then let's look at what they are asking. The vet decides to treat any dog that tests positive for the virus. So let's look at the probability that they actually have the virus. Given they test positive. Okay, so now we're looking at just the positive testers. Positive testers is 2960, and of those, how many actually have the virus? 980, which tells me, if I divide those, 980 divided by 2960, that 33% of the dogs that test positive actually have the virus, which means the majority, or 67% in this case, the majority actually don't have virus. Okay, so if we are treating all these dogs that are testing positive, the majority of the time what's happening is that they don't actually have the virus. Okay, now you may go ahead and decide to treat them anyway if it's not very expensive to treat them and it's not going to harm them by treating them. But if this was like cancer, right? Like if we test positive for cancer, you know, I would probably want to make sure that I actually have it before they start pumping me with chemo, you know, that type of thing. So they're going to run a second test on me to make sure that I actually do in fact have cancer before they start, you know, doing all of that. Okay, because that's what happens the majority of the time. Yeah, the test is 98% effective, but what that really boils down to is having a very large, you know, inaccurate result at the end. Okay, so hopefully that made a bunch of sense. If on your homework assignment they give you all of this stuff, go ahead and make a table out of it. Make a table that looks like that. Okay, all right, there you go.